Good evening, ladies and gentlemen. Your host, Golden Zulu. So today we have one interesting discussion under the standard normal distribution. So there are times whereby in our daily classes, they ask us to say, how did they get this one and that zero there? So in mathematics, we can read this to be the standard normal distribution variable z is normally distributed between 1 and 0, where we need to pay attention to one thing. So the thing that we need to pay attention to is we can write this z to be an xy because x and z, they are corresponding under the standard normal distribution. So we can say that if x is normally distributed between mu and sigma squared, remember we referred to this mu to be what is referred to as the mean, and we refer to the sigma squared to be what is referred to as the variance, and this is what is referred to as the mean. In other words, it's what is referred to as the mu or the mu, as it is called by many. Then we need to understand under the expected value of x. Remember, under the expected value of x, you referred to this to be the mean, also referred to as the mu in this term. So what we will do, remember in our preamble, we said that this x is corresponding to the z. So what we will do here is we will replace this x with the z. What am I trying to put across? We have what is referred to as the transformation under the standard normal distribution. So the transformation that we are referring to is this transformation which we have here, where mu is the mean and sigma is standard deviation. Remember, there is a difference between sigma squared and sigma. Sigma alone is standard deviation, while sigma squared is referred to as the variance. So what we do now is, remember we have said that this z is what is here, isn't it? Then we know for sure in mathematics that an equal sign simply means that the value of this z is what is here. So let us now replace on this z, we put what is here. So we will have the expected value of x minus mu over sigma. Then remember, under the properties of expectations, when we were dealing with it, we said we can always factorize a constant. In this case, standard deviation is a constant number. Remember, in your grade 12, if you find that the variance is 4, if you were to square root the variance, you will get your answer to be 2, and that 2 can also at times be referred to as the standard deviation. Any number you square, as long as it is the variance, you square root it, you find what is referred to as the standard deviation. So from here, we will now factorize sigma, and it will come outside, and you will have 1 over sigma, the expected value of x minus mu. Where now in mathematics, remember, what is outside can also be distributed to what is inside. And when we are told to distribute the expectation to what is inside, you do not need to write it repeatedly, like for the second time, like in English, where you are told to say, if you put the consecutive in one statement, it shows to say it is repetitive, meaning it is wrong. What am I trying to put across? So 1 over sigma, we know to say if we were to multiply e times x, we will get the expected value of that, and e times that. Remember, the expected value is what is referred to as the mu, also the mean. So we do not multiply the expected value to the mu. We just leave them the way they are. Then remember, in our preamble, we said that the expected value is the same as the mu here, which is the same as the mean in other words. So we can replace here with our mu minus mu, where you know for sure that mu minus mu is equal to 0, and any number regardless of any state multiplied by 0 is still a 0. So this is how they calculated the value of this 0 which we have here. Then, having done what we have done now, what is our next calculation? What is our next thing? What are we doing next? So what we are doing next now is we want to calculate the value of the 1. Remember, under variance, we were told to say that the variance of any number under the properties in our first video, we said that the variance of any constant number is 0. There is no variability in a constant number. And we said that the variance of ax is the same as a squared, the variance of x. Let us now check the values which we are getting immediately. Now we are told to do what we are doing. So now that we have this, so let us now solve. So the variance of x, remember we said that x is corresponding to the z in our statement there. So x is corresponding to the z, where z in the first thing was x minus mu over sigma. So we will have the variance of x minus mu over sigma. So that is what we have. So let us now factorize this mu, this sigma, we bring it outside. Then remember, if we were to factorize the sigma, we bring it outside. We are now dealing with this property which is here, which is our number 2. So we will have 1 over sigma squared, open bracket, we have the variance of x minus mu. Then, under the variance properties, we had the third property, which read to say that the variance of ax plus b is the same as a squared, the variance of x. Remember, b in this case is any constant number, and we read to say there is no variability in a constant number, for sure that this is becoming 0. Now that we know that there is no variability in a constant number, what am I trying to put across? Remember, mu is the mean, and a mean is any value which exists in the universe. So if mu is any value, which means it is the same as this b, so there is no variability in this mu, and we'll have 1 over sigma squared, the variance of x. Then remember, in our preamble we said that this is what is referred to as the mean, and this is what is referred to as the variance. So we will now do what is referred to as substitution under algebra. So we will replace the variance of x with sigma squared, where sigma and sigma will cancel and we'll have a 1. So this is how they derived this one together with the 0 under the standard normal distribution. Your host, Golden Zulu.